today's topic is distributed data, and basically a lot about a pattern that is called event carried state transfer. And we established that at LeanIX over the past months, and I basically wanted to share some learning and how we decided to go forward with this, and yeah, things we stumbled across, so to say. So first of all, yeah, a short note on me. So my name is Per. You can find me online via my nickname, Per Programming. I live in Bonn. I think almost like 15 years. So, but I also grew up like only 20 kilometers from here. And LeanIX is actually my fourth professional position. Before that, I was at a web agency and also to other companies, and yeah, learned a lot on the journey, and now quite happy to be part of the platform tribe at LeanIX, where I do a lot of engineering, but also dev and ops, which I all like very much. So looking on today's agenda, I would start to talk a little bit about why you even would want to distribute data, right? Because if you don't know why would you do that? And then I quickly talk about some patterns that I learned in the course of establishing this stuff, where I like to differentiate, and also like other people like to differentiate between certain patterns of distributed data. Then I will hit some technologies that you might be interested in, and then like I guess like half of the talk would be on how exactly do we do that at LeanIX. So what did we decide for? How do we implement it? And then finally, I'm glad to answer some questions, but yeah, don't shy to ask questions on the way, because I think it's sometimes more adequate to respond when the topic is on the slide, right? So feel free to jump in at any time. So why distributing data? So like 2 weeks ago, I gave a talk on communicating in a microservice architecture, and that's actually quite an interesting topic, and it was worth a talk on its own, because what I saw quite often in the past years is that when people implement microservices, they tend to integrate them quite intensely and quite synchronously. So what that basically means is I see a lot of companies that actually do HTTP calls between their services to I don't know, get some user data, or yeah, some data that they need, want to I don't know, present that to the user, or want to act upon it to enable some other feature. And so basically what you see is that it's a quite integrated architecture where all services call one another, and mostly in this architecture there are only a few services that actually have state, right? Because many services don't actually have state, but synchronously get it from other services. And in my experience, that does not work quite nice. So when you scale and hopefully be successful as a product or as a company, and all the user interactions get more and more, you notice that all this synchronous integration stuff is not very resilient. So imagine some network problems. Hopefully you have like retries in place or circuit breakers to work around that. But it's not very easy to scale that, right? And that is why in my experience, it's way more resilient, and in the long run, also way more maintainable to strive for an architecture that more looks like this. So basically, what for me is always like a rule of thumb is that any service that is called by a user to fulfill some feature, some duty, some product ability should basically be able to do that without interacting with any service synchronously. That means actually the service needs state, because without state, well, there are only like limited features that you can provide to a user that do not have state, right? So So basically what you see here is that really each like product feature has its own front end, back end, and state. And what's a bit noted here is that obviously there are some types of data that you probably need in all of the services. So the most simple example would be like a user profile, right? So this is what is the problem to this architecture is that you basically need a way that a user profile is stored in all of these services, right? And that is what I mean here with this light gray arrows, that you basically need a way to share the data between the services. But the most important thing is that you don't do that synchronously, but asynchronously. So you do not do that while you talk to the user, but most perfectly before the user gets to you and perhaps ask you something where you need his profile for. Yeah, so there are a lot of books on that. Two I want to highlight. So one is called Enterprise Integration Patterns. Like the first chapter of it very, very nicely describes about why event-driven and asynchronously integrated architecture are way more resilient than synchronous communication. And then like the other 6 chapters of the book basically explain every single type of event-driven integration that there is. And yeah, it's quite nice because it's like a long list of patterns that you can dive into or even look up later. Yeah, so quite a nice book. The other one I mentioned is by Sam Newman, his second book on microservices, and it's basically like the path from monoliths to microservices, and it helps a lot, especially for these companies that start with the monolith and try to split it into microservices by simply replacing object calls by network calls, right? And then basically ending up with still having only one database, a lot of microservices, a lot of synchronous network calls. And also there, the book has some nice chapters that explain why that isn't a good idea and how to navigate around that. Last but not least, some add on a presentation by myself. It's basically the one I gave like 2 weeks ago, which goes a bit more into detail about all these pros and cons of different types of communication. Feel free to have a look. So basically, integrating your microservices via an event-driven or asynchronous integration for me is the way to go, and I'm quite happy that we also do so at LeanIX. So, but then when I first, I don't know, like 5, 6, 7 years ago, when I first started to think about how to integrate services with events, basically you ask yourself, so how do you do that exactly, right? And so there's a nice a nice blog post by Martin Fowler, which describes at least these 3 patterns that helped me a lot to distinguish some notions of how to integrate services. And I will quickly talk about them. So the first is event notification. The second is event carried state transfer, and that's basically what we do at LeanIX. And the last one is event sourcing. So looking on event notification, imagine you have 2 services. One is service A, one is service B. Then what event notification means is that you use a message system, so a queue, to basically send a very small notification that is passed to the other service. Or, I mean, in reality, it would be pulled by the service, because that's basically the idea behind queues, that the service B can pull the stuff whenever he wants to. And so the huge important notion here is that these small events do not actually carry a lot of information. So it is more or less a very concise description of what happened, but not the involved data. So normally it would only have like a URL or an identifier that service B would then use to call back service A if he really needs that data. So one example would be, I don't know, an event that says user 17 has changed his profile, but the event would not carry the profile, but then service B would actually make a synchronous call to service A to get the profile of user 17. So what's nice is that basically like the events are very small and they're also very, so basically the API that you span up with this small events is obviously quite stable because you only say like, I don't know, a user change and an ID. So like the structure of the user is quite stable, at least on the event stream. And also you can quite nicely integrate this pattern if you already have like a REST API, because Service B can then basically call the existing REST API to get the data. Problem is you are back to a synchronous call, right? So what I learned is quite bad in this pattern, and we did that at my previous company, is that the more services you get, you run into the problem that when a user changes, a lot of services will make a synchronous call to that specific user profile, and hopefully then you can scale. There it was not too much of a problem because we were very good at caching, but yeah, obviously because you have like these synchronous calls again, scaling is an issue, right? So that is where now the idea of event carried state transfer comes into play. And to put it very, very simple, the idea is that you again have a queue, but now you put the actual data on the queue, right? So it's not that you need to ask for it, but any data that you would need is basically part of the events, which basically removes the problem of needing to ask for data later on. So that scales very nicely. One downside of this is that it can happen that basically the same copy of an event is basically replicated a lot over multiple queues. So in the end, people tend to say that if you do event carried state, you end up having a lot of data on your queues, right? And yeah, so that is at least something that you need to consider. And then last but not least is event sourcing. And yeah.
Just to jump in here, I'm wondering, so you have this queue of events for event carried state transfer or for notifications, and you have N subscribers, like 5 different services that subscribe to the queue. How does the queue know, or who knows which event was last consumed by which service? Because when service A fetches the latest event and knows about it, and then service B comes along and hasn't fetched the last 3 events, it of course needs to start at the earlier one. So who keeps track of, is there a queue for each service, for each subscriber?
No, so basically what you would have is like one queue per provider. So like if service A wants to offer some of its data, it would introduce a queue for that. And now what you need to understand is that a queue is basically no more or less than a linear table in a database, right? And so your question is basically, so who can connect to that queue? Well, basically everybody who has the credentials for that database, right? So and the important stuff is, and that's also basically in all of these more event-driven things, it enables you that service A doesn't even know about that there is a service B, or I don't know, like 20 services that are interested in the events, because basically whoever gets the credentials for the queue can start reading on it, and which basically then also answers the second question. So to put it quite roughly, the responsibility of remembering where on the queue I need to consume events is always on the side more of the consumer, right? So there are some queues that manages that for you. So Kafka would be an example where basically you as a consumer subscribe in a way so that Kafka also manages your state. But there are also many queues that actually really say, well, the notion of where on the queue I am, so where in the linear list, is basically something that service B needs to persist on its own, right? Yeah, and so it's also like a nice question because it's actually a problem with like the next pattern. So let me describe that, because what event sourcing is about is that you basically turn things around.
I think Jan wants also to jump into the discussion.
I don't know if it makes sense now or after this slide. I was curious. So as you are domain-driven design, so you have your entities, you have your, so you're kind of modeling your aggregate, and was curious. So you have usually your aggregate, which relies on different entities, which models constraints and stuff like this. And I was curious why you don't model this as a service. So because you still have the issue here in this approach that you have no one caring for constraints that carry over different entities. So in your example, you have the state of the user profile split over 3 or 5 services. And you kind of, in domain-driven design, you have the aggregate, which would care for that every field is there and combined. And we once modeled this as a service as well, which is working identically as you did here. So which was kind of listening on different service queues and aggregating these and matching for constraints. And I was wondering if you are not stumbling into the same issue here, as no one is responsible for consistency and constraints between these aggregations.
So yeah, there's a lot in there. So and I think that later on there will be some slides where I dive into event modeling. And I really love that you bring up domain-driven design, because our experience at LeanIX and also at my previous positions was that if you offer such an event stream, hopefully you have a strategy in place like domain-driven design. Because what's quite important is, like, events on an event stream is an API just like a REST API, right? And so basically, I would say, what is the duty of the provider, being service A here, is to model events in a way that they're as stable and as small as possible, because it is an API, right? So, and also like the aggregation and the entity and the constraints is very important when it comes to how exactly do your events look, because if you model them incorrectly, it can happen that basically in your provider, you only change like a single record, but then need to send like thousands of events, right? And that is, is like an indication for not modeling the events correctly. I try to get back to that topic later on, but it's really good. So I would try to say, well, all this event stuff always looks like, yeah, you send some events and you don't care who is listening. That does not mean that it's basically irrelevant how the events look, right? It's very important to model them and to keep track of their structure very intensively. Yeah, I'm not sure if that answers the question, but yeah, let's see. Perhaps later on gets more clear. So, but in terms of like the larger patterns, so what event sourcing does, it says, well, if you express your whole domain problem, so basically the product that you're building, in terms of event, what you can then do is basically make the queue your database, right? And most of all, that has a lot of advantages within your service, right? So there is a lot of stuff to how you actually implement a certain product functionality within service A that can be quite nice if you do that only concerning about events. And what you then do is you put all these events in a database, and actually that is your state. But that has a problem, and that is basically now you really need, depending on your product, very large queues, right? Because actually you have all your data in your queue. But if you do that, and you should more do that because of the advantages within the application architecture of your service. But if you do that, then obviously you can gain some advantages in terms of how can I now expose this state to other services. But the crucial point is event sourcing is all about making the event your persistent. And what I always struggled with is, so most of the books and blog posts are on event sourcing because it's basically, I would call it like a hype, or like it's the most fancy way of doing things. Like all the conferences, like the speakers are talking about event sourcing because that's like the most modern art of doing things. The problem is that normally is quite difficult to introduce in an existing landscape and an existing architecture. So if you have like, and I mean, like most of the startups or successful company, they won't ever start with this, right? So they will start with a prototyping application, having a Postgres, iterating, getting successful, and then eventually you have like your databases, so your relational databases on your application, and then somebody comes and says, yeah, but it's way cooler if you just have a queue as the database. And that's not something that you can basically introduce in a sprint or so to say. So that is, to me, the most difficult downside of this thing is that it's not very easy to introduce that later on. If you are a new startup that has a lot of money, very experienced developers, it might be a good idea to do that. And actually, I was on another meetup some days ago where someone talked about this, and it was actually like a prototyping company, and they did that very successfully. And so if you start on a plain field, there are actually really great technologies that do all of that for you. So let me give examples. So at least in the Java ecosystem, there are frameworks like Akka, which is actually Scala, but still running on the JVM, or Vertex or MicroStream, that basically solve all of your persistence problems, right? So what you basically can imagine that as an event sourcing solution that has so many abstractions layers on top that you really, at least from what I saw, can basically start coding your domain problem and no longer care about how to persist and then scale your application. So it's really impressive. It looks very shiny, very nice. But again, the problem is that is nothing that you can basically throw at your existing application, because it's more like a full-fledged approach to it that you hopefully start with and not try to introduce later on. So that's at least my impression. But to be honest, I never worked with this, but from all like the presentations I saw, seems nice, but hard to integrate later on. Then again, there are like, well, queue technologies, right? So I mentioned Kafka, and also RabbitMQ is quite a famous one. So this would be looking on this event and queue problem just from a perspective of I need a database for that, right? So I need a queue. So then actually Kafka and RabbitMQ are like the most established one, I guess, at least again in the Java ecosystem. And we actually use a Kafka queue at LeanIX for, I don't know, I guess since the beginning of the company, more or less, so more like 8 years. And yeah, what we learned in the meantime is what's actually quite nice is if you are able to use managed stuff, right? So we at LeanIX are glad that we can use Azure as our cloud provider, and Azure and also the other cloud providers like Google and Amazon, they come with managed queue solutions, right? Most of them have the RabbitMQ like protocol. Azure Event Hub actually also allows you to use the Kafka protocol, which is quite nice. But the most important stuff is that you do not longer need to maintain or manage the queue. So basically all the things like scaling it, making sure that it has failover in place, backup stuffing, all of this, like running the stuff problems are basically what you pay for, and that's quite nice. Yeah, long story short, what we ended up using is the Azure Event Hub, because we do not want to manage it on our own. And again, it's very hard to introduce like this more framework approaches in an existing architecture. We do not need to manage it, so it's not like this this lower level problem of really running the stuff on our own, but it is also not like this really big architectural idea that you somehow need to get established at your company. Then again, it's basically on Azure, which we use quite heavily. So LeanIX loves Azure. That's why that was the obvious choice, and not go, for example, for the Amazon product. It has a very nice pricing, great documentation. It's scalable, as I said, fully managed, and there are a lot of SDKs. So there are SDKs for Java, Node, Go, so basically whatever you want. And all of that well maintained, nicely documented. So again, you notice that Microsoft basically is a software company, and you always feel that when you use their products, right? So they know how to do the stuff. Yeah, and also like the pricing is really nice because you can basically dynamically or using infrastructure as code, basically like scale the queue to your needs, and you only pay what you need, right? So you can start very slow, and also like we run our products on multiple continents, and we have continents where there is not so much traffic, so we can use a small queue, don't pay so much, and then we have like regions like Europe where we have a lot of traffic and a lot of events, and there we just scale up, and we can even do that in the course of a day to basically always have like a nice pricing. There's one problem with the event queue that basically enables them to sell it at such a low price, and that is that events will only last on the queue for 7 days. So regarding your question, Konstantin, so if a service would not consume events for a week, it would basically have no clue what happens 7 days before that, which basically also means that you cannot use Azure Event Hub as an event sourcing solution, right? Because yeah, it's just limited in terms of how long events keep being persisted in that queue. But also there we come to that again later on. Yeah, because now I would try in a bit more detail to describe how we now actually use the Azure Event Hub to do an event carried state transfer, right? So there are like 4 sub topics I want to catch. One is event modeling. That's basically also what Jan already mentioned. Then there's a thing that we call a replay. Then we introduced a support service at LeanIX that solves a lot of problems when it comes to the notion of, well, the queue is only there for 7 days. We call that the event collector. And last but not least, I will try to describe some details that you need to be aware of when doing something like an event carried state transfer when it comes to consistency. So starting with the event modeling. There is where I think if you do not have a method like domain-driven design in place, you can badly fail, as you would with a REST API, right? So if you do not think about which is basically, what is my state? How do I shape it so that my API doesn't get too complicated, and also not to force clients to couple very closely to my service, then you will end up having a bad time, right? And exactly the same holds true for an event queue. That's why we, so when a team at LeanIX introduces new event stream, we have documentation and also like workshops in place that helps them to understand what an aggregate is and what entities are and what reference by identity is, and all these things that are in domain-driven design. Why I also think that is that is very important is So I'm a huge advocate of you should model your services along your product features and also along your teams, or the other way around. Teams should basically own dedicated services. So there shouldn't be a service that is owned by multiple teams, because basically you end up perhaps being able to scale technically, but not organizationally. So also there, having a good idea on like the data of your product, the features of your product, how that interrelates, and how you can nicely find domains. So certain areas of problems that you can decouple from other areas, and thereby also like decoupling the teams is very, very useful. And that's why I always say domain-driven design is a really helpful methodology. Yeah. Looking on like event modeling. So what we came up with is that we introduce 3 types of events. That's basically what I tried to show here. So the upper left is quite simple, because what that basically says is whenever you have a certain aggregate, so a certain boundary of data that needs to be consistent, then that aggregate comes with change events. And at least with the 3 events at least with the event created. So there might be aggregates that only can be created and they will never be deleted. It's not very often, but so at least every aggregate has the notion of I was just created. And basically the event has the then existent full state of that aggregate. And it's guaranteed that that state is consistent within this aggregate, right? The second thing is it might be that the aggregate changes. What you would then send is an update event. So if there is, for example, a consistency rule in 2 properties of an aggregate, you would never send that as 2 events, but you would send an event that basically changed the consistent transition of the aggregate. So basically, all these events normally in the producer have like a transaction around them, right? And last but not least, it might be that there are aggregates that are being deleted. So then you would also be able to have a delete event, which no longer has any state in it, but simply expresses that the state that was beforehand described by create or update events is then gone. So with this, you would normally be able very roughly to offer an event stream that a consumer can consume and replicate its state from. But there are 2 problems with that. So one is you made a mistake with your events. So it might be that you didn't actually follow the consistency rules, or you notice, as you would do with any API, well, that property I would prefer to call something different because it helps you to better understand the state, right? So you rename a field, for example. And whenever that happens, it's basically the question, how do you communicate that to the consuming services? And that is where we introduce the concept of a replay. So what a replay means is that, and that is basically organized by the 3 events on the right side, that on the queue, you communicate via an event that you want to do a replay. And what comes, basically what a replay means is there is a certain number of entities of a certain aggregate that I want to replace because I know that there's a problem in them. And the duty of the consumer is when it gets this and starts replay event, that it will now wait for so-called state events, so that you see on the lower left side, that basically are quite similar to the created event, but they are called state events because they have the latest state of the entities. And you would then consume all of them. And when you finally get an end replay, you know that now you know the full state of all the entities within this replay. And you also know that any event that you got before the replay is now invalid. So basically it allows you to, so if you would have an aggregate in a single database table, the most easy way to implement a replay on the consumer side is when you get a start replay, you just truncate the table. Then comes a lot of state events, which you basically insert to the table. And when the end replay comes, you basically are done. And you could perhaps use something like a transaction around the table to even never have like an empty state in your table, right? But basically this is the idea behind the replay, that it enables you to take a certain amount of aggregates and say, I need to replace them. So with it is basically quite easy to have a API change. You still need to communicate that to your consumers as you would with an API, like a REST API. They need to release a version that can handle both versions of the events, but then finally you can basically switch over to this new type of events and move on. So this is where basically we introduced this replay idea. So now some examples. So all of the events will always have a type, which basically describes that whether it is a change, a command, or a state event. And then we also introduced what we call a class. So that basically describes the aggregate. So which type of entity is it? Is it, I don't know, it could be a user. Here at LeanIX, we have things that are called fact sheets, and they come in different types. So basically you can, compare it to a Java class, right? So this is basically what the class attribute represents. ID is what is the identity, what you would also have like in DDD, that such an thing has a unique global identifier that you can identify it with, at least global within the class, right? So that's what you need to respect. Then with change events, there is always an action. So this is create, update, or delete. And now this is interesting as a scope. So scope basically allows you to have a group of such entities that you will want to be able to replay, right? So here at LeanIX, we basically have a way, so call it multi-tenant, right? So basically each customer has like certain areas where they have their data in, and we call that a workspace. So most likely the scope of an event is that it belongs to a certain workspace. So it belongs to a certain customer, right? And what we can do now is if we notice that something is broken for a customer, we could, for example, only replay the single customer. But if we want to introduce a breaking API change on our events, we could also replay like all customers. Then we would do many replays of all these scopes. And then last but not least, there is a state where like the actual state is in. An update looks quite the same, except for that it has the action updated, and it may only carry the state. No, it can decide to only carry the state that actually changes. In contrast to a created event, which would have like the initial state of all of the existing properties. And then again, like the deleted event, where you see that it don't has a state, but it simply again references the same class and ID and expresses that that thing is gone. So now looking on a replay, what you would then see is an event that says, I want to replay. And now you see that we basically tell what the scope is. So basically we say it's a certain customer or a certain area of data that we want to replace. And after the replay comes, for example, three objects, three events that are basically all a state event, which means that it has all the actual state of the data in it. And then finally comes an end replay. And with this, we can basically tell a consumer to replace everything that has the scope workspace foo with what now is between these two events. So yeah, that's the idea of a replay, put quite roughly. So event collector. So as I said, one problem, so to say, but actually that it's why it's so affordable with the Azure Event Hub is that the queue is at max. It persists events for only 7 days. So normally that wouldn't actually be a problem, right? Because hopefully you would never have a service B that consumes the queue of a service A that is down for 7 days, right? You have it resilient, you do all your testing and DevOps correctly. So basically service B is up and running. So let it be down for a minute, but so normally there is no problem that you basically read all events within 7 days. And because of that, you would actually be not interested in something that happened before then. But there's actually a quite simple situation where it might be relevant to know what happened like a year ago. And that is you introduce a new service, right? Because if you introduce a new service and say, I have a new product feature, and in this new service, I want to have the users, then basically you would only know the users of the last 7 days and perhaps even only like change events or update events on them, not that there's anything created. So it might even be that there's no new user or a change to user in the last 7 days. So you would know nothing about any user. So initially we thought, well, then let's just do a replay, right? Because if we do a replay, there are new events on the queue. The new service can read them. The new service has the state and can start making its users happy. The problem would be that so whenever you replay something, these events are obviously consumed by our services, right? So if you have like 40 services, you introduce the 41st and you say, well, then I need to replay everything. Actually, all of the 40 services that already exist and have a perfect state would start to update their state without any need. And so here LeanIX, as an example, like one of our more prominent aggregates has, we call it the fact sheets in West Europe that are 50 million entities and is roughly like 40 gigabytes of data. And that wouldn't actually be a very good idea whenever there comes up a new service to send that over the wire just because the new service wants to have all of the state. So how did we solve that? Well, we introduced another service. It doesn't know anything about the other services and it only knows all the queues. And what it does is it basically consumes the queues and persists the state to an Azure Blob Storage. So what we basically have is an Azure Blob Storage where all the state of all scopes of all entities and all aggregates is persisted basically as text files where there's a JSON line for all of the entities in it. What that enables us to do, if there's a new service, we can basically let him read from the Azure Blob Storage to initialize its state. So that would be the most interesting feature we get out of that. Here's a quick example. So what you might see here is that it's basically organized by the aggregate. Then you also see the scope. So this would be a certain workspace. And then you see that there is for every single type of data is basically a text file with all the entities of the respective data in it. Yeah, and that is quite a nice way to basically consume that. What's important, and you see that up here. So basically the queue comes with two things. So one is called, one is called partition. So that has something to do with scaling. So basically, actually an event hub at Azure is not like one queue, but like 32. But that's really only about scaling. So it doesn't really change something conceptually on all of this event stuff. What's more important is, so imagine that you use such a text file to initialize your state, then the question would be, so how now do I keep the state up to date? So you would do that with the queue, right? Because you would see change events there. And for any text file that we offer via the blob storage, you see here in the upper right corner that it is within a folder that has a number on it. And what that number is, it's basically the position on the queue where you need to start to read to now keep that state consistent with what is happening on the queue. So basically, whatever you see in this like state files in the storage, there's always a sequence number that allows you to basically keep it consistent with the events that are now being produced on the queue.
So whenever the blob storage persists a new event, the folder name is incremented by 1 per event.
Yeah, that would be the case if we, for every single event on the queue, would create a new folder and copy all the files over, right? But that would not be so efficient. So we roughly do that once per day. So basically what we do is every day, the event collector basically looks on what he created yesterday in the storage, has a number on it, and now he starts to read the queue on the number. So basically he reads all the events that happened during the past day, updates the state with it, so applies changes, applies deleted, and when he is done, he creates one new folder, put the stuff in there, and put the new number on it.
I see. I thought there was one 40 gigabyte file for the whole thing, but actually you have many files for many snapshots of the queue, and if you put them all together, you have the whole thing.
Exactly, that's how it is. So what you might, so if you are more into queues, there's actually one very important thing. So if you want such a queue to be consistent, the most important thing on that queue is the order. So that's actually what differentiates it from a normal, I don't know, SQL table, right? And that is whatever you put in there has exactly the order in which you put it in there. And you would also always consume it exactly in the order as it was put in there. So the order of events on the queue is guaranteed. And that's important because you can imagine, I don't know, if you would have to update commands in the wrong order, to update events in the wrong order, it might be that you end up with the wrong state, right? So that's why order matters. And that is why we learned that it's very important as a producer. So if you're somebody who wants to write to the queue, so it wants to expose the state that it has in its, I don't know, for example, Postgres database, produced on a queue, then it's very crucial that it can guarantee that the order of the events with which it describes the state are in the correct order. And what we learned is, so what you typically would do is, so imagine somebody starts a replay. So what you would basically do is, you would select the data from your Postgres table and send it as events, right? But what we learned is it's obviously a bad idea to do. So imagine you have like 20,000 records and you want to replay all of them. It would be a bad idea to shut down the database, now read like all the 20,000 events, guaranteed to put them on the queue in the right order, and then again enable the product for your customers, right? So what's very crucial is while a replay happens, users are allowed to change the data. So now how can I guarantee that if the data changes, I reflect it correctly in the replay? And so what's very important, so as a basic message, and that's also something that I learned like 4 years ago, if you read something from a table because you want to send it on an event stream, then you need to lock it for updates. So what you see in the upper right here is that so basically we put a transaction on the single record. So it's the fact sheet with the ID FS1. but we do not do only a select and then insert it into where I want to send an event with that. But I also have a for update in here. What that ensures is that between me reading the table and expressing that there should be an event with a certain order, like 1, 2, 3, that there's not a concurrent request that makes an update on the fact sheet and expresses like the update event as an event in the event outbox. So basically, if you do not lock your table for update when you read from it, at least the single row, then you basically are not guaranteeing that the change in state events on the queue are in the right order. So it's a very, very small example, but we really invested again at LeanIX, like, I think it was like a month to really understand what are like the basic golden rules a producer need to respect when he tries to express a consistent state in a high concurrency system, right? And we basically put that into our documentation and have able to have a workshop on that to explain in like our most prominent programming languages and their persistence technologies. How are you able to guarantee that the order of events is in the correct order? Yeah, so that's something that you also need basically to get your head around when exposing state via an event stream. So put quite shortly. With that, I would be at my last slide and happy to take more questions.